From the smallest of subatomic particles to the grandest galaxy clusters, the universe is a symphony of mysteries. But among its most enigmatic players are the entities so extreme, so powerful, they warp the very fabric of reality. And these are known as black holes. Are these cosmic titans merely destroyer, or do they hold the key to unlocking the universe's deepest and profound secrets? So this is what we are going to discuss today. Welcome everyone to this cosmic chronicle. We are diving into the heart of the darkness, exploring objects that have fascinated scientists and sci-fi writers alike for decades. They are the ultimate cosmic enigmas, which are black holes. And with us today, we will shed the light on these on this incredible phenomena, and we will discuss all these points today. So let us start with the basic for those who might not entirely familiar with what exactly is a black hole. In simple terms, a black hole is a region of space-time where gravity is so strong that nothing, even light, can escape. Not even light. It can form when a massive star collapses in an itself at the end of its life, compressing an incredible amount of mass into an extraordinarily small place. So it is actually it's not a hole in the traditional sense, but more like an incredible dense object. Imagine taking something with the mass of our sun, squeezing it down to the size of a city. The gravitational pull becomes so immense that it creates what we call an event horizon. This is a point of no return. Once you cross that boundary, you are on a one-way trip. That's truly mind-boggling concept. For a long time, black holes are theoretical. We did not know existence of that, and so how did we confirm their existence? So Einstein theory of general relativity predicted their existence over a century ago, but they inherently difficult to observe directly because they don't emit any light. Our confirmation came through indirect methods. We observed their effects on surrounding matter and the superheated gas spiraling into them, emitting the X-rays, or the way they influence the orbit of other stars. And of course, the groundbreaking detection of the gravitational waves by LIGO in 2015, which were ripples in space-time caused by the two black holes colliding, providing a very very strong proof. That was incredible moment in science. Now that as the title of the show is today, we ask, can the black hole reveal the universe's deepest secret? This implies they are more than just a cosmic vacuum cleaner, or what kind of secrets we are talking about here. So this is to answer this question. It's going to be very exciting. Black holes are extreme laboratories. The physics near a black hole is unlike anything we have experienced on Earth, even in the most of the universe. They push the boundaries of our understanding of gravity, quantum mechanics, and even very nature of space-time. Let's break it down on these secrets. Firstly, they are 100% linked with gravity, and in order to understand gravity better, we need to understand the black hole, or vice versa. In order to understand black hole, we have to understand the gravity. Our current understanding of the gravity comes from Einstein's general relativity, which describes gravity as the curvature of space-time. Black holes are the most extreme example of this curvature. By studying how matter behaves around them, how light bends, and especially when gravitational waves are generated during the black hole merger, we can test general relativity to its limits. If there are any deviation or any subtle cracks in the current theory, black holes are where we are most likely to find them. This could lead to more complete theory of gravity. This is arguably the deepest secret black hole holds. and it will also help us unravel. At the singularity, the point of infinite density at the heart of the black hole, both general relativity and quantum mechanics breaks down. This gives us conflicting predictions. However, the presence of black hole forces us to confront this problem. A theory like string theory or you know loop quantum gravity are attempting to reconcile these two pillars of physics. Understanding the information paradox, for instance, which is about whether the information that falls into the black hole is truly lost, could be a crucial step in this unification. Quantum mechanics tells us that the information is never truly lost. It might be scrambled, but it's always conserved. But if something falls into a black hole and the black hole eventually evaporates through Hawking radiation, does that information just disappear forever? So Stephen Hawking himself initially thought it was lost, but later revised his view. Many physicists believe that information must somehow be encoded in the Hawking radiation, but we don't yet understand how. Solving this paradox would give us profound insight into the fundamental laws of universe. A groundbreaking concept proposed by Stephen Hawking, and he says that it's a quantum effect, that it means that the black holes aren't truly black. They slowly evaporate over incredibly long time scales. This is where the quantum mechanics and general relativity clashes, and the clash is most dramatic. Supermassive black holes, which are millions or even billions of times the mass of our sun, sit at the center of most galaxies, including our own Milky Way. There is a strong correlation between the mass of these central black holes and the properties of their host galaxies. They can regulate star formation within the galaxy, sometimes shutting it down through powerful jets of energy or sometimes triggering it. Understanding this co-evolution helps us piece together the puzzle of how galaxies form and evolve over cosmic time, and by extension how large scale structure of the universe can can form or become a reality. We are on the cusp of some incredible advancements. The Event Horizon Telescope, which gives us the first ever image of black hole shadow in 2019, it continues to bring upgraded images. It is being upgraded also with latest tech. More sensitive array will give us even sharper images, allowing us to test Einstein theory even more precisely around the event horizon. Then there is a next generation of gravitational wave detector like LISA, the Laser Interferometer Space Antenna. This will be a space-based observatory sensitive to much lower frequency gravitational waves, allowing us to detect the merger of supermassive black holes, which are far more common than stellar mass black holes merger. This will open up a new window into universe. We also have an X-ray telescope coming online that will provide unprecedented views of extreme environment around the black hole, revealing more about the accretion disk and jets. Every new observation pushes the boundary of our knowledge. I think for many physicists, it would be direct evidence of quantum gravitational effect near a black hole, something that unmistakably point us towards a unified theory of everything, or perhaps detecting a wormhole, which is a theoretical shortcut through space-time, even if it is not traversable by human at this point in time. Anything that truly forces us to rewrite our fundamental textbook. They are ultimate cosmic laboratories, pushing our theories to their breaking points and forcing us to think about the universe in entirely new way. They are extreme, mysterious, and profoundly beautiful in their ability to illuminate the very fabric of reality. So, friends, thanks for joining me on this cosmic chronicle. From the elegant dance of galaxies to the terrifying beauty of black hole, the universe continues to whisper its secret. And as long as there are minds curious enough to listen, we will keep searching for those profound answers. Until next time, thanks for watching. Bye for now.